Hey everybody, how's it going? Welcome back. Today's the exciting part. We actually get to go to town on some non-fungible tokens. So this is kind of what this is all about. This is the type of asset that really kind of, it's the reason Flow exists. So it was built by the team behind CryptoKitties. CryptoKitties was, for anybody who doesn't know, kind of the thing that really got this party started. People really got excited about the fact that you can create these digital collectibles, use them for gaming, and really, I mean, to me, the most exciting thing about it is after playing, certain video games. For me, there's a hockey one that stands out, being a stereotypical Canadian. But most of those games where you're spending your hard-earned money on digital assets in the form of either playing cards or whatever, really downloadable content that you can't get a return back out of your investment or trade outside of the game. That's really what they're talking about when people mention walled gardens and what we're trying to get away from. So non-fungible tokens give us the ability to create game assets or collectibles, artworks, music. People are using them to divide up pieces of physical real estate. You name it, but they're just a really exciting new digital asset that allows us to really do some special things. And I mean, going back to kind of what I was talking about with resources in combining the best parts of both a physical and digital asset, we're now able to trade these digital things that we couldn't take out of their original environment as if we were trading dollars or say Magic the Gathering cards or whatever. We can actually take those outside and trade them, get a return back on our investment. In some cases we can actually increase our original income or increase our original capital. But this is what it's really all about. This is what you're seeing kind of take off on Ethereum, well, before DeFi did, and this is really what Flow blockchain was built to, or this is the market that the blockchain was built to serve. So let's get into it. I could blab about it for probably another hour without really saying anything. So let's start taking a look at what we're actually building today. There's going to be two examples of this contract. So the first V1 that we're working with here is going to be a really simplified version of a non-fungible token. We're basically just building the contract, building a resource within it, setting an ID and a metadata dictionary in here. But that's really, you can see that when we initialize it, there's really nothing inside the metadata. So just kind of showing that we can store this stuff, but we're not actually using it. And then we're just going to save it and run a transaction that checks if the non-fungible token exists. So that's step one. Step two, we're going to work on a bigger example, like a more realistic example of this non-fungible token contract. So we are going to do what we did in the first step, but we're also going to add a couple of interfaces. I guess for this one we're just going to add one interface, but it's going to be a collection, and this is a new design pattern that's going to be quite different from the fungible token example. This is how we actually store. So this would be like our vault of non-fungible tokens, but it's a little bit beefier than the example we went through last week with fungible tokens. So we'll be able to go through. This is still a fairly simple example of a non-fungible token, but it does get all the basics covered. Like, this is kind of the basics that you would add to any non-fungible token before you customize it and truly make it your own. So quite a lot to go through today. Still going to be a pretty quick stream, but feel free to ask questions, leave them in the comments, please do, and I will get back to them, or the chat. I guess we are live, so if anyone does care to join today, feel free to fire some questions in the chat. It'd be great to have some two-way conversation. Okay, so just to get started, kind of going back over it to help my own brain again because it's been a few days, but we're just going to create a public contract. We're going to name it non-fungible token. Just for the sake of clarity, while I'm still doing this, I'm just going to name it V1 so we can see what gets deployed over here a little easier. And so within this contract, we're going to create a public resource. We're going to call it NFT. We're going to give it a public ID field. This is a constant, so once it's set, it won't change. That makes sense. And then when we initialize, we're also going to set a dictionary, which has a string key and a string value called metadata. So this is where we would map, you know, if it had a type, you know, a level, experience, that kind of stuff. We'd be able to kind of map it in this metadata string. This is a super basic example, so nothing too crazy yet, but just to show you kind of where your individual tokens data would live. And then when we initialize this contract, we're just going to save a new NFT with an ID of 1 directly to the NFT1 namespace in account storage. So very simple. So we've deployed it. You can see that the new name's in there. Just going to change this so that we're actually importing the right thing and it can find it. So in this transaction, we're just going to import our contract code from account 1. And then it's a very simple transaction. So we're just going to take our signer and we're going to borrow the NFT from the storage, a reference to the NFT from the storage. So this is where we saved our NFT that we just created. And we're going to log that the token exists if it finds it. So if it's not equal to nil. Otherwise, if it doesn't find it, we'll just log out no token found. So when we run this transaction with account number 1, just making sure that you can see that, good stuff. If we run this with account number 1, we'll see the token. So we should get, just because I didn't change the name. So this namespace is where it's looking to find this NFT. So you need to make sure that these match. Rookie mistake. So the token exists, but you'll see if I try to run the same transaction with account 2, because we don't have a token stored in account 2 storage, we'll get the other message. No token found. So that's really it for example 1. We're basically just creating a token, saving it to storage, and checking if the token exists. Kind of not much different than what we've done so far. So we'll leave that there for now. I'm not going to rename this contract just because we'll get enough difference here and I don't want to have to go through and rename everything in the transactions, because we'll probably run into a few of those error messages that are so fun to run into when you're live on a stream. So anyways, for this one, all of the transactions and scripts that we're going to run from, like going forward, are going to be from account 2. So this is the smart contract that we're really going to spend the most time with. So this is going to be fun because we're actually going to be able to create NFTs. We should be able to mint them to the accounts, and then we should be able to deposit and withdraw them as well. So way more of a full featured demo. So we'll start off just doing what we did before. We're going to create an non-fungible token contract. We're going to create a new public resource. We're going to create a new public ID. Sorry, we're just going to create a public ID field for the resource, and we're going to, yeah, we have no metadata for this one, so we're just using a bare bones example. These will just have, the only difference between these NFTs will just be their ID number, but that's okay. That'll do what we need to do for this, and you can definitely customize those on your own time. So when you look down at the initialize method, we're just passing in an ID, which is a uint64, and we're just going to set that to the field, and that'll be that. It'll never change. So now this is where we're using our interfaces. So this is a good example. For the NFT receiver, we just want to expose the deposit, the get IDs, and the ID exists methods. So that just basically, it's like those are the public methods that you really want anybody to interact with. You don't want anyone withdrawing or doing anything too crazy with your NFTs, but these are all safe methods. We want to be able to let somebody put a token into our collection. We want to be able to check which tokens exist in our collection, and we want to be able to check if a specific ID is within our collection. Those all make sense. So that's our receiver that we'll use. You can see that when we create our public resource collection, that we're setting the NFT receiver as our interface. And so this is cool. Like, this is kind of where my brain really had to start working when I started working with Cadence, because this is kind of brand new to me, the concept of a collection over a vault. So back in the fungible token stream, there's a huge difference here. With fungible tokens, we would create a vault, and that vault would, like, the fungible tokens themselves were really just an integer value. So the original contract had what was it? Let's just open that up and have a look, because it's so easy. So we had a total supply, integer, or I guess a fixed value up here, and this is really what the tokens were. We were just increasing or decreasing this total supply value, but they weren't, the token itself wasn't an actual resource or an asset that was really being passed around. In the case of a non-fungible token, this totally is. So you need a different way of withdrawing, depositing, and keeping track of which tokens exist in the collection. So you'll see in this case, we're creating a collection, which is like a vault of NFTs. And then within the collection, we're keeping track of the token ID and the actual token itself. And we're storing that in this dictionary here with a special @ sign, which just lets us know that, hey, this dictionary actually contains resources, so we need to handle it as if it was a resource. So moving it, destroying it, we can't treat this resource dictionary just like a normal dictionary. So when we initialize this, we're just going to initialize it with an empty dictionary, because we're going to be creating an empty collection. And then we get down into our withdraw method here. So this is only going to be accessible to the owner of the collection. There's no interface that controls this or lets the public use it, and that's what we want. So the withdraw method, it's public, but only if you have access to it. So only if you have access to the capability or the actual physical collection and storage will you be able to call this withdraw method. So we're going to pass in the token ID that we want to withdraw, and we're going to return the actual non-fungible token resource itself. So you can see in the comment up here, we're using the force unwrap. So if we do try to withdraw a token that doesn't exist, it'll just revert the transaction, because this will be nil. So just to explain, we're creating a token variable. We're moving the self-owned NFTs. Sorry, let me just see here where we're getting that removed from. Yeah, so remove is a method on the self-owned or the owned NFTs dictionary. So every dictionary will have that remove method, and we remove it by the key. So that's the token ID that we pass in here, and that's the key value that we have there. So if there's a value, the value will be returned. If there's no value there, it'll return nil and revert the transaction. And if we have that value, it will return the token. For our deposit method, we're just going to pass in the token itself. So this is, you'll see this when we do, when we're dealing with resources. In the case of a resource dictionary, we would pass the token in at the ID. So this is the token ID that we're using for a key. And then if there is a value in there, we need to make sure that we destroy it. So we're moving the old value out into this old token variable. So we just need, we read this line from right to left, and then destroy whatever's in that old token variable. So we do this regardless of whether the value in owned NFTs is nil or not. So whether or not this token exists, we just do this anyways to clear out anything that might be there. And that's the way that we deal with resources, to make sure that there's nothing just kind of hanging out in memory. So the ID exists method, pretty simple. We just pass in a token ID and we return a boolean. So we're going to return the result of basically what happens when we pass in this ID. So it'll return true or false based on whether or not this value is null. So get IDs. This will just return an array of all the token IDs in our dictionary. So this is another really simple one. We just return the keys method that belongs to the dictionary. So the keys method just returns an array of all the keys in the dictionary. In this case, they're UN64s. And then finally, we just have a destroy method. So this is when you create a resource that contains other resources. So we have a resource dictionary in here. We need to do something with those if this resource itself, the collection resource itself, gets destroyed. So in this example, we're just going to destroy the entire dictionary. It's important to note because this did come up a couple times during OWB, where this isn't necessarily the right way to do it. In our projects, we were building some safer destroy methods. So, you know, if we have a collection being used somewhere, instead of just destroying all those NFTs that are in there that probably have some value, you should probably think about what to do with those instead. So should you be sending them somewhere else or whatever? But this is where you'd handle that. And then at the end of the day, you just destroy the empty resource dictionary. So just pointing that out, just destroying the resources within a collection is probably not the best way to go unless that's your intent. So create empty collection is just a method on the contract, and this just returns a new collection with no tokens in it. And you'll see we use this any account that's going to want to receive NFTs will need a collection before they're able to do that. So you'll see this being used in order to kind of set up an account in order to perform a transaction using the NFTs from this contract. And so the NFT minter, this is a resource itself. It would be like an admin resource. I can't remember. Let's just have a look. Yeah, okay, so we did build a vault minter, and this will be really similar to the vault minter that we built in the last demo. Just 1 second. So it'll be really similar to the vault minter that we created in the last demo, where this is like just belongs to an admin or say a site or something like that that would actually be controlling the minting of NFTs, and it just allows a trusted source to go ahead and handle the actual creation of these assets. So for the NFT minter, just read, sorry, this is something that I don't normally build, so. Okay, cool. So this is just an incrementer, just to make sure that we get the right ID. So it's a var because it is going to increment when we initialize. It's going to be set to 1. Just assuming so that we don't have NFTs with an ID of 0. And the mint NFT method that's going to exist on this minter will just, so it looks like this is actually going to send it directly to the receiver's collection. So yeah, this is actually kind of cool because we get to see, so it's a public method. We're passing in a recipient. And so this is the first time we've seen this any resource, I think. So this is a reference to any resource with an NFT receiver interface. That's what that means. And that's really cool. You're going to see it in a couple of later tutorials when we talk about composability. So this allows you to pass in any NFT as long as it has that receiver interface and that functionality on it. So without going too deeply into it, there will be, similar to Ethereum, like fungible token and non-fungible token standards, and those will be something that we do get into on a later stream, where we can actually use like a preset structure to then build our contracts on, or our non-fungible tokens on. And if we use that, then the hope at least is that the developers will be building their contracts to work with those types of contract standards or those types of token standards. So you should technically be able to use this any resource type and just specify which interfaces that we're going to be using. and everyone would be able to kind of have just a better layer of compatibility between their contracts and tokens. So that's the hope. It's really cool to actually see that in use this early on, but that's what that does. So we'll be able to pass in a recipient, basically any NFT receiver, and that would allow us to send them an NFT. So I think I hope I didn't confuse things there, because I think I just kind of realized a couple of limitations that I might not be going into, but I don't want to hang on that too long because we are just into the basics right now. So if those become an issue, we'll do a video about it. It'll be great. So we're going to create a new NFT. So again, just creating our resource. We're using our ID count here to set the ID, and then we're going to increment that ID count after we're done. So returning that here, we're depositing that into our recipient's NFT receiver. See here, we're using the move. So that resource is then handled. We don't need to destroy it or anything. It's living somewhere. We've handled it properly, and that's where we go ahead and just increment our ID count value so that the next token has ID 2. And then store an empty NFT collection in the account storage. So this is where we're initializing this contract. So for account 2, we would save an empty NFT collection into their storage NFT collection space. We'd publish a reference to the collection in storage. So link a reference to the interface itself, which is the same as doing this. But we don't need to. So that's just cleaner. And so we're going to save that to public NFT receiver and target the collection that we saved up here. So that's creating our public capability, and that allows others to borrow it and deposit or get the IDs from the collection. And then we're going to store a Minter resource in account storage as well. So this will be our admin account. We're going to give this account the ability to actually mint NFTs, and we'll pop that to a different location in storage because it is a different resource. So that's that for the contract. We're going to deploy. And now we can actually start working with it. Okay, so for transaction 2 here, we're going to just mint and deposit an NFT. So we're importing our non-fungible token contract from account 2, setting up a couple of fields. So a field for our receiver reference. This is just going to grab a reference to that NFT receiver interface. And sorry, it's going to store the reference to the NFT receiver interface. And the minter ref is going to store the reference to our NFT minter. So we're going to get the account object and get the capability from the NFT receiver in public storage using force unwrap so that we revert if we don't find a value there. If we do, we're going to borrow the NFT receiver interface, a reference to the NFT receiver interface. And if we can't do that, we're going to panic and say that we couldn't borrow a reference. And then down here for our minter reference, we're going to borrow just a reference to our NFT minter. And that's stored at NFT minter in account storage. So that's a reference to the physical, well, I keep saying physical, but that's the reference to the actual resource that's in storage, not to a capability like we've created up here. And then in our execute block, we are going to call the mint NFT method on our minter, and we are going to pass in our receiver. So yeah, we're going to run this from account 2, which makes sense because nobody else has the vault set up yet. I'm just going to clear the console before we run it. Cool. So we have an NFT minted into the accounts collection. And you can actually see that here under storage if you look in the NFT collection. Just trying to look. So here's our actual collection and the fields and values that we have for it. And then within this is our dictionary of owned NFTs. And you can actually see in here we actually have an owned NFT. So pretty cool. We'll see it in a script as well, but I don't think we get there for a little bit. So I just wanted to have a look. Cool. So we've deployed, or sorry, we've minted and deposited. Just gonna have a quick look at our scripts. So that'll be used after the next step. Okay, so for transaction 3, this is the setup stage. So this is where we create an empty collection and create a public capability for that collection. So this would be, we would run this, and we will run this on accounts 3, 4, and probably account 1, just so that we can actually get some tokens moving around. So for this, we have, again, import our non-fungible token contract. That should be getting pretty familiar at this point. And then we're going to grab our public account object. Oops, sorry. First, we're going to create a new empty collection. So we're going to create it. We're going to store it. And then we're going to grab, or sorry, we're going to save it to our account's public object. We're going to save it to the NFT location and storage. And then right after we save it, we are going to link a public capability. So targeting the actual collection and creating a public capability to the NFT receiver interface, which again just provides people with the safe methods. So the ability to deposit a token, the ability to check the IDs in the account, and the ability to check if a specific ID exists within the account. So once we have this deployed, let's do it for account 3 because that's what the tutorial is calling for. So we've created a collection for account. Oops, I guess this is what the tutorial is calling for. Okay, so we've actually created a collection for account 1 and created a capability for it. So account 1 now has a NFT collection that we can deposit and mint NFTs to. Keep wanting to call them rocks because I built rocks in open world builders as a super exciting example. Okay, so we've set up our NFT collection. So we're going to actually transfer. So we're going to withdraw from one collection, deposit to another collection, and we'll actually be able to see the NFT. Yeah, we'll actually be able to see the NFT change hands or show up in the other account's collection and remove itself from the first one. We'll have to check storage for that because we're just looking at the back-end code, but that's what we're doing. So, okay, so import our contract. We're going to create a new field for transfer token. That's going to be the actual token that we're sending. From the signer's account object, we're going to borrow a reference to their account collection. And we're borrowing the actual collection reference and not an interface reference because in the next step, we're going to call the withdraw method and we're going to withdraw a token with ID of 1 from the account. So that's what we're going to pull out and store in our transfer token variable. And then in the execute method, we're going, or in the execute block, we're going to get the account object for account 1. So that's getting our public account object. Similar to, well, not really. Never mind. Just forget I even said that. We're going to get our public account object for account 1. And then we're going to look for the capability for the NFT receiver using our force unwrapped. If we find it, we're going to borrow a reference to the NFT receiver interface. If we can't find that, we're going to panic, revert the transaction, and let everybody know we fell on our faces. And then we're going to deposit the transfer token into our receiver's collection. So it sounds like a lot, but these are all steps that are pretty comfortable once you actually get going. So I think we're going to, yeah, we're gonna sign this with account 2. So we're gonna pull that NFT. It's the only NFT that we have created. It's the one that we created in the last or a couple steps ago. We're gonna pull that out and we're gonna send that to account 1's collection that we just created. We got a happy little message to let us know that everything worked. So when we look at account 1 storage, we'll see that NFT with the ID of 1 is sitting in account 1 storage. If we go to account 2, oh, I feel like that's not completely right, because there should still be a collection here without any tokens in it, but it's definitely changed. So we should be able to see that. There's some scripts that we're gonna run, because that's the end of the transfer. So let's see what we got here. So we check account 2's. Yeah, we check account 2's collection and see what we have. Comments say 3. We can't be fooled. It's account 2. So that just returns an empty array. So there are no IDs in that collection. That's what we expected, because we transferred. We sent the token from account 2 to account 1. So if we check both accounts, we can see that account 1 has a token, account 2 does not. And that's really it. Like, I mean, for the tutorial at least, it seems like a lot, and at first it kind of is, but it's really just the basic set of features that we're doing. So creating a collection, giving the ability to add and withdraw tokens from it, deposit and withdraw tokens from it, checking what tokens live in the collection, and just doing a quick yes or no search on whether an ID exists. I am going to go through just where we minted. Yeah. Okay, I'll just mint another token to account 2 here, just because I want you to see a difference between the last script output and the current one, right? So just to kind of keep going a little bit on it, is we originally minted an NFT, we deposited it to account 2, and then after setting up a vault, so this is really like the important steps that I feel like I kind of went through pretty quickly, so I just want to touch on. So we created this token, this transaction, we run it with account 2, and it just mints an NFT into account 2's collection. It has to be run from account 2 because account 2 is the only one that has control over this minter. It actually stores it. So in the first step, what we did is we minted the NFT, deposited it into account 2. The step after that, we actually created a vault, we created a collection and a public capability for account 1, and that allowed us to actually transfer the token that was in account 2 over to account 1. So if account 1 never did this, never set up their collection, this would fail, this would revert, and account 2 would still own that original token, because it wouldn't have had anywhere to send it. There would have been no reference to borrow. So that's really why step 3 happened before step 4. Step 4, we actually transferred that token into account 1, and that's where I kind of went off track a little bit and started looking at the storage. And then again, oh yeah, now you can't see that because my face is up there, sorry. So then what I did was I just went ahead and minted another token for account 2, which used that incrementing ID from the minter. So you can see that account 2 now stores token ID 2, and that was what I minted and deposited into account 2 after we transferred token 1 over to account 1. So just as another step, because now we're just having fun, let's go back to this transaction, mint another token. Account 2 is just balling. And then what we're gonna do is, we already created a vault for account 3. That was my mistake when I first ran this transaction, but have no fear, we're gonna make use of it, because now all we need to do is change where we're sending the token. So this is gonna be wrong, but that's okay. Uh-oh. You have a collection. Tried showing off, and now things are going wrong. Oh yeah, okay. So it's giving me an error because we're still trying to pull with token 1 out of account 2's collection, but token 1 doesn't live in account 2's collection anymore. Crazy kids. Token 1 lives in account 1, and now account 2 has tokens 2 and 3. So I've updated. We're gonna transfer token 3 to account 3's storage collection language, and we're gonna do that signed by account 2, because account 2 is the one that has control over their collection. So we did it. The error message is wrong. We actually sent it to account 3, but it's okay. And then what we're gonna do here, we're just gonna add the third account so that we can show all 3 accounts balances. This is where I'm missing VS Code massively. I'm probably gonna have to run this one a couple times because oh, that's nice to see that they have that. I don't miss VS Code as much now. By that I just mean like the quick duplicating of the lines. Oh, life changing. Okay, I didn't press save. I feel like I deserve a gold star. So we have migrated, or we have transferred the NFT from account 2 to account 3. So we should see that now all 3 of these accounts have tokens. Yay. And their respective token IDs as well, because I'm just super organized like that. So I mean, that's the super basic look at NFTs. I don't want to go much deeper than that right now. We could definitely look into token standards and adding, you know, metadata, kind of using some tricks to change what type of tokens get minted at what block height and that kind of stuff. But I'll leave that for now. Like if you want to continue to noodle and push it, then definitely go that route and try playing around with some of this stuff and actually building a more interesting custom NFT. But for now, like the basics that you really want to get your head around are in this NFT V2 example. The interfaces, again, this is where they become super important, because this is really when you're starting to get into some more sensitive stuff, right? Like your NFTs should have methods that only the owner should be able to run. But that said, they should still have kind of getter methods that the public can use to figure out, you know, what it is, what it does, and just basically get some general insights into any data that you might want them to have access to. So you will definitely want to use a public, like at least one public interface, and start thinking about how interfaces can help you control who has access to what. The collection is huge, like wrapping your head around this pattern in general, because you're going to see it all over the place. So the collection, this is the gist of it, right? Like you're going to see, you want a way to control what the collection actually owns. In all cases I've used, it's always been a dictionary. It's typically using a token ID and storing the resource directly. The collection will contain the ability to withdraw and deposit, as well as some kind of high level, again, kind of getter methods to just say, hey, what's in there? You'll want to have the ability to create a new resource for your collection. So you want to have this create empty collection method for sure. And minters, and this is kind of cool, right? Like this is a standard idea of creating a minter resource and providing it to an owner. So I mean, the other cool thing about this is you can change the way this contract is deployed. Say account 2 could create the contract, and that could be where the contract is stored, but maybe account 1 is actually the admin for it, and maybe account 1 handles all the minting and stuff. So you can send this resource to account 1, and any of the transactions that we've run for minting tokens signed by account 2, you'd then have to sign with account 1. But yeah, that's really it. Like, I mean, this is really the fun stuff, because you want to wrap your head around kind of the basics of how an NFT is built. You know, how it's stored, what kind of methods to put on it, and once you get like the super simple implementation down, then it's really exciting, because you can just build this super custom piece of code that if you're paying attention to the industry right now, it's kind of changing the world. So the world is kind of your oyster when it comes to what can this do and what can this represent, and we're really seeing new ideas every day around what NFTs can do. So that'll be it for the demo. Hopefully you got something out of this, because I feel like I bounced around a little bit, but yeah, like exciting. I'm excited. That's why I'm bouncing around, because I'm just losing it with excitement right now. So have some fun with it. Definitely chime into the Flow Discord if you have any issues. Ask some questions, fill up the comment section, please do, and we should be back on Thursday. What do we got next? Marketplace. Ooh, yeah, the marketplace will be pretty cool. I mean, everything's kind of cool at this point, so we're getting into some real use cases for things. Marketplace next week. What's really nice about that is we kind of go deeper into the whole composability side of things. So this is where you're going to see a contract that makes use of fungible tokens and non-fungible tokens, which will both be imported from other contracts. So stepping it up yet another notch. The other thing I liked about this tutorial was the fact that you actually really get to see, you know, all of this tech in use, and some kind of more exciting demonstrations of transactions. Like, just, it's really cool to see account 1 has $40 or 40 fungible tokens, account 2 has 2 NFTs. You make the transaction and you actually see the money and the NFTs changing hands. That was exciting. So yeah, get pumped up. This is like I said, this is where things get pretty real. So on Thursday we're gonna jump into the marketplace tutorial, and until then, have fun with non-fungible tokens, and we'll see you next time. Thanks for watching.